Okay, I'm going to do a set of video solutions for the 4.4 practice number 1, which focuses on a review of 2x2 linear systems. So let's have just a quick look at a couple review problems. First few problems I asked you to solve a system of equations algebraically. And so here's an example of problem. This is stuff you guys did in Algebra 1, and you would have reviewed it last year in geometry, and it's going to be really simple for this group. But just a quick review. Remember that our two methods for solving a linear system algebraically are substitution and elimination, or sometimes it's called linear combination. So let's go ahead and because this is an example where y is isolated in at least one, in fact, both of the two equations. So then we could just we could take, for example, that equation and make that our substitution equation and substitute the expression negative x plus 4 in for y in the bottom equation, and then we end up with negative x plus 4 equals negative x plus 2. If I subtract, or if I add x to both sides, I end up with 4 equals 2. 4 equals 2 is a false statement. And so what that means is there are no solutions to this system. These lines, they never cross. Remember that when we solve a linear system, we're looking for the values of x and y that simultaneously satisfy both equations. Graphically, that means the place where the two lines intersect. So these lines would never intersect, and we can see that because they both have a slope of -1 but different y-intercepts. We probably could have anticipated this from the beginning. Okay, so this would be an example where there are no solutions, so we would just enter NS. Okay, next. Let's skip up to a little harder one. Wow. Okay, this is a pretty easy one. Yeah, let's look at this. This is an example of one where it's set up in standard form. And so unless it's really simple to isolate a variable, which it is, we'll just use linear combination. We could, for example, isolate y in the bottom or x in the bottom equation, and it'd be pretty easy to do and then substitute. But let's go ahead and just use linear combination here. So if we leave the top equation alone, and here's how those of you who had me last year, and most of you did, remember this is how I like to do my elimination method. That one stays the same, so we just draw an arrow, just a plain arrow. This equation we're going to multiply through by 3. And remember, our reason for doing that is so, for example, if we look at the x's, actually let's multiply by -3. Either one would work, and we can talk about that later. We want to multiply by something so that we can get at least one of the variables to cancel out when we add the two equations together. So we'll multiply by -3, and that gives us -15x plus 15y equals 0. And now notice what happens when we add those two equations together. The x's cancel and the y's cancel, so we get the answer 0 equals 0. Well, that is always true. And so that implies that these are the same, both of these two equations represent the same line. And so there's an infinite number of solutions because all of the points on each line lie on top of the points on the other line. So this one would have a solution. Just real quick, well, I'll do it on the next one. Okay, this would be another example where we could just use substitution. No big deal. I'm going to skip that one. You guys don't need that. And then here's one more example of standard form equation. So this is one where we could just add those equations together. And if we do that, because we can already see that the x's line up so that when we add them together, they cancel. So if I add those together, I'm going to get the answer. Negative 4y plus 2y is negative 2y. And that equals, let's see, we get negative 14 plus negative 8 is negative 22. And so that gives us the answer y equals 11. Now what? So that's half of our solution. Now we would just plug that back into either one of the two original equations to find the corresponding value of x. Pick the easiest one, probably the bottom one, not that it really matters. So then we end up with 2x plus 2 times 11 equals negative 8. And let's see what we get. So if we simplify this, 2x plus 22 equals negative 8, subtract 22, we get 2x equals negative 30, divide each side through by 2, and we get x equals negative 15. So we want to, being as we did get a solution here, we want to write this solution as an ordered pair. So, oops, I meant for this to be already open for you, but I can fix that later. So we don't even really need to use that. We can just put it in right here also. So we get negative 15, 11. Okay. Okay. And I think one of these, maybe this is the one. Did that one have fractions? Yeah, it probably did. Well, I'm not going to do it. You guys can deal with fractions. Okay, so the next part of this, that's just a quick review of stuff that you've already learned a long time ago. But this is presumably new. So now I want to talk to you about how you can solve 2x2 linear systems with technology. Oh, darn it. Okay, so let's look at an example like this. Okay, so here's an example of another linear system in standard form. Let me pull up my calculator. So I want to show you a really good trick here. It's a really simple way to, using technology, to come up with a solution to this linear system. And all you have to do is, I like to call this, we're going to solve the equations into the calculator. So in either case, we're just going to isolate y. So for example, there's y. I'm going to get that y by itself. Okay? So I'm going to open up the y editor on my calculator, and for y1, let's get rid of these. I think I maybe even talked to you once before about this. We're going to isolate y in the top equation. So there's a couple ways you can do this. You can, for one thing, you could use the fraction template if you wanted to. So let's do one with the fraction template. How about? So remember, I get there by going alpha, what was it, alpha F4? No, alpha F1, that was it. There we go. And so on the right side, I've already got a negative 4. That's already going to be in the numerator on that side. Now to get the y by itself, the first thing I'm going to do is subtract 4x from both sides, and then all I've got on this left side is a negative 4y. So I'm going to divide that whole numerator by negative 4. Oops, what did I do? There we go. Divide by negative 4. Okay, the other way I could do this, so there's the first equation where I've isolated y directly into the calculator. The other way I could do this is to not use the fraction template. I personally prefer not to. So if I want to get this y by itself in the second equation, I'm just going to open up a set of parentheses that represents everything on the right side of the equation. I've already got a 10 there, and I'm going to add 2x to that side to get rid of the negative 2x from the left side. Then I'm just going to divide the whole quantity by negative 2. And now all I've got to do is just graph the equation and look for the intersection. Okay, the thing about lines is lines look the same on any scale. And so normally we'd say let's just go zoom standard, which we can do, but we're not guaranteed, because that's a pretty small window, we're not guaranteed to see the intersection. Well, we did this time. This was fine. But why not instead? Just so we don't have to go back and expand our window over and over again. I guess that's so easy to do, you can try it. But if it doesn't show up on the zoom standard screen, then just go into the window and make it something big. Like go from negative 100 to positive 100 on both x and y. And watch what you see when we do this. They still just look like normal lines, right? Lines look the same on any scale. So why not make the window really big? Then all we've got to do is just go second calc intersect. Remember this trick? And then, yeah, the first curve is y1, second curve is y2. My guess, that's pretty close. I can just hit enter. In fact, I don't even have to ever, because lines only have one intersection if they have any, I don't even have to ever move the cursor when I make my guess. And so the solution is x equals negative 3, y equals negative 2. Oops. Okay. There it is. And so those are all the same idea. I probably don't need to go through any more of those. This one's even easier because y is already isolated in the top equation. So I'd make the top one, for example, y1 equals x plus 6, and then just isolate y into the calculator in the bottom equation. Same thing there. Okay. You know what? Maybe I should quickly look at these, because I want to show you something else that could happen. If I'm rambling a little bit, I'm pretty sick. So y1, x plus 6. If I isolate y into the calculator for the second one, I'll open up a set of parentheses on the right. I've already got a negative 2 there. I'll add 3x to the right side, close the quantity, and then just divide. That represents my numerator of the right side. I'll just divide that whole thing by 4. And let's go zoom 6. There's my first line. There's my second line. Okay, those are going to cross, aren't they? So here's another example where I would just, I'm just going to go, why don't I make this one go negative 100, and then I'll just go zoom 0. It's another trick I could do. Okay, and I'll just look for the intersection and just hit enter 3 times, and it's going to give me the answer. Negative 26, negative 20. Okay. Let's see, this guy. Okay, this is a good one. Yeah, I want to look at one like this. So the first one, if I isolate y into the calculator on the right side, I've got 10, subtract 6x to the right side, close the numerator on the right, and divide the whole thing by 8 to get that y by itself. Bottom one, I can enter just the way it is. So y equals, let's clear that, equals negative 3/4 x. And one thing, I'll tell you one other little hint here that's sometimes helpful. If you're not sure where to put parentheses with fractions, if you just enclose all fractions in parentheses, the calculator will always just deal with that fraction just like a number. It just deals with it like a quantity. So if you're unsure, that's always a good hint. So I'll just put the negative 3/4, the negative 3/4 in parentheses. I don't need to, but to play it safe, let's do that. X plus 5/4, and obviously I don't need the parentheses there, but I included them. And now if I go zoom 6, there's the blue line. And what do you know? There's the red line. So what's going on there? Well, they're clearly the same line. The red line is right on top of the blue line. And so this is an example where there are infinitely many solutions because all the points overlap. And we can see that graphically. Okay. If you don't have the fancy TI-84 that has the red and the different colored curves, the way you can ascertain that they are lining up one on top of the other, because you wouldn't be able to see the second line being drawn, would just be to turn one off at a time. So if I go up and I unhighlight the equal sign, that effectively turns off the first curve. So there it is. Okay. If I go back and turn the first equation on and turn the second one off, notice I get the same line. Okay, so then that would be a way, if I didn't have the fancy color addition, that I could still see that they're the same line. Okay, and then finally, what about something like this? Okay, so the first one, if I solve that into the calculator, I get the quantity 86, add 2x to the right side, and divide the whole quantity by 9. Second one, I've just got my 2/9 x plus 23/9. And if I graph those, okay, so those lines appear to be parallel. How do we know? Well, parallel lines have equal slopes. And so here's one way we could do it graphically. Of course, we could do this algebraically by putting the top equation in slope-intercept form. We'd add 2x to the right side and divide by 9. And we could see right away that that would give us a slope of 2/9. But graphically, here's how we can see. If we go second calc, number 6, dy dx, that's our calculus way of saying slope. And so if I want to know the slope of this line right here, I just hit enter, and it tells me that the slope is 0.2 repeating. Okay, so let's do the same thing with the other curve. So we'll go 6, and then I've got to hit the down arrow or the up arrow to jump down to the red line and hit enter, and it'll tell me the slope of the red line. It's the same thing, so therefore they are parallel. And if they're parallel, they never cross, and so there are no solutions. Okay, some real-world problems involving 2x2 linear systems. Okay, and you've seen a ton of these kinds of problems in the past, I'm sure. Oops. Okay, so let's look at something like this. So we've got, I'm going to grab this one and put it on the Promethean board so I can write some stuff. Okay, so something like this now. We've got a situation here where we've got these two rental car companies, and they have different pricing structures. The first one, Easy Rentals, charges a flat fee of $27.06, $27.06. So that means that you're going to pay that up front regardless of how far you drive, right? That's what a flat fee is. And then you have a mileage rate of 10 cents per mile. The other car company, or the rent-a-car company, does not charge any flat fee, but they charge a steeper mileage rate, 43 cents a mile. And so we want to know two things. After how many miles will both companies have charged the same amount? And just round the nearest mile. And then at this point, which we're going to call the break-even point, both companies will have charged how many dollars? And so really what we're doing here is we're going to solve for the two variables that we're going to use in the system of equations that we're going to build. And one good hint is always to just look for what questions are being asked. Like for example, if they want to know after how many miles, well then the number of miles must be one of the two variables. They also want to know what's the total cost. So that's the other variable. Then you just have to determine, which one of those is the independent variable and which one is the dependent variable. With this one, pretty clearly, the price is going to depend on the number of miles. And so what we're going to do, we're going to say then that we're going to let x, which is our typically our independent variable, x is going to equal the number of miles, and we'll say that y equals the cost of the rental. Okay, and so then we just got to come up with these two equations for the two different car companies. Well, let's kind of color code this. So we'll do easy rentals is going to be purple. Okay, so what's that going to look like as a linear equation? Well, we know that the cost is going to equal $27.06 plus $10 per mile. Well, that's the rate, isn't it? We multiply the number of dollars per mile times the number of miles to figure out what the part of the cost associated with the per mile rate. So then we get we'll call this maybe y1 is going to equal 0.10x. There's my rate, plus 27.06. So this term represents the cost per mile times the number of miles. So there's the per mile part of the charge, and then there's the flat fee. What about the other one? And this one's going to be red. So bargain rent-a-car does not charge a flat fee, but we have a per mile rate of 43 cents per mile. So we'll call that y2 equals 0.43x, and that's it. So all we got to do then is solve that linear system. Presumably we'll just do it with technology. Just cross those lines on our calculators. Okay, no big deal. You guys can do that. Okay. What about let's go ahead and do it. Why not? So if we throw those in our calculator, they're already solved for y. It's pretty easy, so let's just do it. So the first one, we've got 0.10x plus 27.06. Second one, 0.43x. And I can already see that y-intercept is going to be pretty big, so zoom standard's not going to work. So let's just let the window, might as well start at 0, right? No sense having, it wouldn't make sense to have negative miles. And let's just go out to, what do we say, 250, something like that. If it doesn't work, we'll just change it. And then we'll go zoom 0. So we'll let it fit the y values for us. Okay, that's all it takes. And it's part of the issue that people have when they use graphing technology to try to solve a system like this by graphing is just kind of getting good at playing around with the window so you can see the intersection of the two lines. Just takes a little practice. All right, so we would just go second calc intersect and then triple enter. And there it is. So x is 82. So the number of miles is 82, and the cost would be $35.26. That was what y was, remember? Okay, and it wants us to separate those with a comma. So we're just filling in the blanks. So how many miles? 82. And how many dollars? 35.26. Okay. Another one. Okay, what about something like this? So we've got, I wonder why there's two. That's weird. Huh. So, I'll fix that there's a little extra dollar sign there. Just ignore that for now. I can fix that easily. Two people are going to eat sushi, it looks like. And look what we got here. Desmond, he orders 8 pieces of sushi and 12 bottles of water at the supermarket. Okay. I don't know why he's getting so much water, but okay. So, and that costs $22.60. Aisha bought 4 pieces of sushi and 4 bottles of water, and it cost $16.75. All pieces of sushi cost the same, and all bottles of water are the same price. So we want to figure out then, what are the 2 questions being asked? What's the cost of each piece of sushi, and what's the cost for each bottle of water? Okay, so then we'll just let X be the cost per piece of sushi. That's one thing that we're looking for. That's one of the unknowns, and the other unknown is, call it Y, the cost per bottle of water. And so then we end up with the linear system. If we do that, let's see. So Desmond will be the first equation. So we end up with 8 pieces of sushi. So let me write down my variables. X equals cost of a piece of sushi, and Y equals cost of bottle of water. So Desmond bought 8 pieces of sushi, so 8 times the cost of a bottle of water, or a piece of sushi, plus 12 bottles of water times the cost of a bottle of water should equal his total cost, which was 22.60. Okay, Aisha, she bought 4 pieces of sushi, so 4 times the cost of a piece of sushi. She bought 4 bottles of water, so plus 4 times the cost of a bottle of water equaled her total price, which was 16.75. And so that's the linear system I'm solving. And once again, we're just going to do this on our calculator. And so in the first one, if we're going to isolate the y. So we're just going to open up. We'll go ahead. This is in the way. That stuff. Okay, so we're going to isolate y. So that means over here then, we're going to open up a set of parentheses. On the right side, we've already got 22.6. And then we're going to subtract 8x away to the right side, close the quantity, and divide by the coefficient of y, which is 12. Oops, forgot to divide. Divide by 12. Okay. Next equation, to isolate y here. We've opened up a set of parentheses. Open up a set of parentheses. We've got 16.75 already on the right side. We'll subtract 4x away to that side. Close the quantity and divide the whole thing by the coefficient of y, which is 4. And now we just got to find where they cross. So let's just go 0 to, I don't know, let's just try like 25 maybe. And then we'll just go zoom 0. So it'll fix the y's for us. Okay. So what do we get here? What did I do wrong on this? Okay, I had to fix something on that. So let's go back to this problem and let's try it again. I had one little error with it. It's all fixed. So same kind of deal here. This time we got different people buying different stuff. Ethan bought 10 bags of jerky and 6 cartons of milk for $23.49. So this time we'll say let's let X equal, we're trying to find the cost for each bag of jerky and for each carton of milk. So X is going to equal cost for a bag of jerky, Y equals cost for carton of milk. Okay, and so then, what are the two equations we get? Well, if Ethan buys 10, let's color code this, if Ethan buys 10 bags of jerky and 6 cartons of milk for $23.44, then what's that work out to be? So we get 10 times the cost of a bag of jerky, which is X, plus 6 times the cost of a carton of milk, which is Y, equals the total of 23.44. Okay? And then, let's see, Heather bought 4 bags of jerky and 11 cartons of milk for $22.19. So her equation would then be what? 4x plus 11y equals 22.19. So there's our linear system. We've just got to find the solution to that. So let's put that into the calculator. Okay, so for the first one up here, if I isolate y into the calculator, look what we got then. So we got already on the let's get rid of all this stuff. Messing up our calculator. So if we're going to isolate y in that first equation, we've already got, we'll open up a set of parentheses on the right side, 23.44. We're going to subtract 10x to that side, close the parentheses, and then look what we'd have. We'd have the 6y by itself, divide the whole thing by 6. And then the other one, open up a set of parentheses, 22.19, already over on the right side, subtract 4x to that side, divide the whole thing by 11 to isolate y. Okay, and let's just go window, let's go from 0 to 25, let the calculator pick the y part of the window for us. Okay, and it's way, so we didn't, that's pretty inconvenient. How about if I just go from 0 to 4, because it would just clear up in the corner. Now we'll go zoom 0. You can see it a little better. And we just go second calc, intersect, triple enter, 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 enter. And there it is. So we get, what do we get here? So we get $1.45 is the value of X, so that's the cost of jerky. And we're just filling in the blanks here, remember? Let's get rid of all this stuff. And so we want, the dollar sign's already there, we're just filling in the blanks. So we put a 145 there, and then second equation, carton of milk is $1.49. Okay, good. And then last one. Okay, what about something like this? Okay, this problem stars Duncan. What do you know? This one's for you, Duncan. So Duncan is designing a rectangular garden for his backyard. He would like the perimeter of the garden to be completely fenced, and he has 32 feet of fencing available. Okay, he wants the width of the garden to be 3 times the length, and he wants to know what should the width be and what should the length be. So let's just go ahead and let x equal width, y equal length. And if it's a rectangle, right, we know that the perimeter of a rectangle, so here we got this statement, we'll make this blue. The perimeter of the garden is completely fenced and he has 32 feet of fencing. So in other words, the perimeter is 32. The perimeter is just 2x plus 2y. Okay, what about the other statement? He he wants the width of the garden to be 3 times the length. So if width is 3 times length, then that's like saying width, which is x, equals 3 times y, which is length. And so we would just solve that system. No big deal. You guys can do that. Okay, there's solution for solution. Done.